Chemical equations are extremely important in any topic in chemistry, which means they can come up in any part of a chemistry exam paper. So we'll just look at a few so people can get used to reading them, understanding them, and completing them. So the first question says, copper oxide and sulfuric acid react to produce copper sulfate and water. Now, I've read that question and highlighted it in 3 different colours because the yellow part shows what I'm given, which needs to go at the start of the chemical equation. React to produce is shown by an arrow, and then the product, what's made, are shown on the right. So using the correct chemical terms, I've got reactants and products. So all I've got to do is copy those terms onto the lines. So copper oxide and sulfuric acid reacts to produce copper sulfate, and water's already there. And that's 1 mark for copying those things onto the correct lines. It wouldn't matter if I swapped copper oxide and sulfuric acid to each other's lines, but they must be on the left of the equation because they are my reactants. Now, in this question, I'm not asked to complete a chemical equation. I'm asked to use one, and they've put it in symbols. So the equation for the reaction between zinc and copper oxide is, so there's the zinc, there's the copper oxide, they're my reactants, and I'm producing zinc oxide and copper. But it's not super important that I'm able to name those in this question. It says 1.30 grams of zinc fully reacted with 1.59 grams of copper oxide, 1.59 grams, to produce 1.62 grams of zinc oxide. What mass of copper was produced? Now, in this case, I can use the chemical equation and turn it into a math sum. So 1.30 grams plus 1.59 grams equals 1.62 grams plus something. So I need my calculator for this question. So if I just do the first half, I'm going to move down onto the line. 1.30 grams plus 1.59 grams, 2.89 grams equals 1.62 grams plus my mass of copper, my unknown. So now I need to rearrange my equation. At the moment, my unknown is plus 1.62. So I'm going to minus 1.62 to remove that and do the same to both sides. So 2.89 minus 1.62 equals my mystery mass of copper. So typing that into my calculator, I get 1.27. So used in a certain way, a chemical equation with masses can become a math sum. Now the next question asks me to balance the equation. What that means is I need to make sure there's the same number of each atom on both sides. Now the easiest, some people might be able to see straight away what needs to be done. I'm not one of those people, so I'm going to list what I've got. I've got Li and I've got O. And then I'm going to separate the left-hand side and the right-hand side. I can see at the moment, I've got 1 lithium on the left-hand side and I've got 2 oxygens on the left-hand side. On the right-hand side, there's a big 2 in front of the formula. In maths, you'd put brackets around that and it would be 2 times everything in the bracket. So in the bracket, I've got 2 lithiums, but there's 2 lots of that, so I've got 4 lithiums. There's 1 oxygen in the bracket, and there's 2 lots of the bracket, so I've got 2 oxygens. So now I can see where my imbalance is. I need 4 times more lithiums on this side, so I put a 4 on the line. In the next one, I'm going to do the same thing. I'm going to list what I've got. So I've got Mg, I've got H, and I've got Cl. So on the left-hand side, I've got 1 Mg, I've got 1 H, and I've got 1 Cl. On the right-hand side, I've got 1 Mg, I've got 2 Cls, and I've got 2 H's. Now where I can see my imbalances, I need double the amount of hydrogens and chlorines. I can do that in one go. If I put a 2 there, that's the same as if that was in a bracket, remember? I've got 2 lots of hydrogens and 2 lots of chlorines. Next one, list what I've got. So I've got Al and I've got O. On the left-hand side, remember, a big number before multiplies the whole thing. If it helps you to draw brackets, do it. Some people can do it without drawing them. They can see it anyway. But now I can see I've got 2 aluminiums in the bracket, and that's times by 2. So I've got 4 aluminiums on the left. I've got 3 oxygens in the bracket, and that's times by 2. So I've got 6 oxygens on the left. At the moment, I've got 1 aluminium on the right and 2 oxygens on the right. So I need 4 times the amount of aluminiums. I need 3 times the amount of oxygens. Again, another balance the equation. So writing out what I've got Na and I've got Cl. On the left at the moment, I've got 1 Na and 2 Cls. And on the right, I've got 1 of each at the moment. So I can see I need more Cls on the right. I need twice the amount, so I'm going to times it by 2. But although that gives me 2 Cls, remember, big numbers times the whole thing. I've now got 2 Cls, but I've now also got 2 NAs. I've got another imbalance. I now need double the amount of NAs on the left, so I need to times that by 2 as well. Then we've got another mass question. So 4.6 grams of sodium reacts with chlorine to produce 11.7 grams of sodium chloride. What mass of chlorine reacted? So I've got 4.6 grams of sodium plus my unknown mass of chlorine makes 11.7 grams of sodium chloride. I'm following the same pattern as the equation above. Now, at the moment, I need to get Cl on its own. At the moment, it's plus 4.6, so I'm going to minus 4.6 from both sides to find out how much Cl there is. So Cl is going to be 11.7 minus 4.6. Type that into my calculator. And that's 7.1. Now another balancing question. So complete the balanced equation for the reaction for sodium and water. So again, listing what I've got. Na, H, and O. On the left, I've got 1 Na, I've got 2 H's, and I've got 1 O. On the right, I've got 1 Na, 1 O, and I've got 3 H's. I've got to be careful because I've got 2 H's there and 1 H there. So I've got 3 H's. So it's my H's that are out of balance. So what I'm going to start off with, I'm going to try and fix my H's. So I'm going to start by timesing this by 2. It's a little bit of guesswork. I'd probably do that in pencil because I'm not certain, but we'll see how it works out. So now I've done that by 2. That's 2 lots of all of this. So I've got 2 lots of H2, so I've got 4 H's now. I update my numbers. I've got 2 lots of O, so I need to update that number as well. Now it makes sense. I need to fix my O's and my H's. I need another O on this side. I need to times it by 2, and I need another H. If I put a 2 there, that gives me 2 O's. So I can update that. It gives me 2 NAs, because remember I'm timesing the whole thing. It gives me 2 H's here, and remember I've got my 2 H's here as well. So I've got 4 H's in total. But in doing all of this, I've now messed up my NAs. I need 2 NAs on the left, so that balances. I would have done that first number in pencil because I wasn't sure. And then if I'd have been wrong, I could have rubbed it out and updated my numbers. Maybe I could have tried a 3, but it worked out the way I did it. Now, this question is about hydrogen chloride. Now, I'm focusing on the balancing the symbol equation, but I've left the question in before because it's going to help me. I'm not doing about covalent bonding in this video, though, so I'm not going to answer question A. But this one says, complete the balanced chemical equation for the reaction between hydrogen and chlorine. Now, I can see in the part above, it makes HCl. I also know that obviously I need to add chlorine, but I know chlorine comes in 2s. Again, I know that from my knowledge of bonding, which I'm not doing in this video. But I just want to point out there can be things like that where you may have to know some formulae, especially on higher tier. Now I need to balance it. I know I've got 2 H's on the left and 1 on the right. I know I've got 2 chlorines on the left and 1 on the right. So it's clear that I simply have to times this entire side by 2. Now the next one, complete the equation for the reaction by writing the state symbols. So there are 3 states of matter: solid, and its symbol is an S; liquid, symbol is an L; gas, symbol is a G; and anything dissolved in water is known as aqueous, which is AQ. So that's if I dissolve a salt or something in water. So I know zinc oxide, if I read the question, a student reacted zinc oxide powder. A powder is a solid, so I put an S. With hydrochloric acid, now I know acids are dissolved in water, so I put AQ. To produce zinc chloride solution. Solution means it's dissolved in water, so I put AQ. Plus H2O. H2O is water, so it's a liquid.